Okay, this is a walkthrough of Master Exam FA Practice Version 1 and problems 4 and 5, which are very closely related. They're also related to problems 1, 2, and 3, kind of using the same idea. In this one, just to copy down, we're still using a function, a particular function. Let me just copy down the formula for it. It was f of x equals 2x squared minus 3, or plus 3x minus 3. Put the x in parentheses there, it doesn't really matter. And in the previous 3 problems, what we were doing is we're plugging in different values of x, and sometimes the x's are numbers, and sometimes the x's are expressions, like a squared and so forth. And that's where we find ourselves here in problem 4. I'm asked to take this function up here, this polynomial, and evaluate it and completely simplify f of a plus h. Okay, and again, the key point that we raised in the previous screencast was this x, think of it as just a blank, or maybe just a big red dot. You know, we have to replace all those x's with big red dots, and whatever you put here in the blank also goes everywhere the blank is on the right-hand side. So let me just do this first of all. F of blank equals 2 times blank squared plus 3 times blank minus 3. And in this case, in this problem 4, we're asked to fill in the blank with a plus h. Okay, well here I go. I'm filling in the blank with a plus h. Okay, this is what it means to say f evaluated at a plus h. I'm just going to replace the input with a plus h, whatever that is. And now on the right-hand side here, I have a lot of algebra to do, and that's where some mistakes can be made. But this is the big conceptual step right here, just replacing the x with what it says to replace it with here in the parentheses. Now let's work out the algebra on the right-hand side. First of all, I have this a plus h squared to work out. That's a difference of perfect squares, and so you can go up here and write that out if you want to. Again, FOIL method is what we would use here. A plus h squared is a plus h times itself, and using the FOIL method, just box this off here, that would be a squared, outer would give me an a times h, inner would give me another a times h times a and a times h are the same thing, and then last would give me h squared, and so this simplifies to a squared plus a couple of these ah's, 2ah plus h squared. And that's what this thing here is. Okay, so the thing I've underlined simplifies to, let me just put this in red to indicate the step I'm doing, a squared plus 2 times a times h plus h squared. Close the parentheses. And now I'm just going to copy the rest of the expression down. No need to do a whole rush of things here. Now the next step here is just to multiply the 2 through this parenthesis and the 3 through this parenthesis. And that's going to give me 2a squared, okay, multiply here, plus 4ah, all the way across here, plus 2h squared. Now I've got to do pretty much the same thing here. Multiply there, that's 3 times a. Multiply there, that's 3 times h minus 3. Okay, so all the squaring and all the distributive property stuff has been done. Now I just need to make sure that see if I can completely simplify this. And for this kind of expression, it means look for like terms. If you see a couple of like terms that can be combined, do so. Now let's see what we got. There's an a squared term here, but there are no other a squared terms. There's an a times h term, but there are no other a times h terms. There's an h squared term and none of those. There's an a, no more of those, and an h, no more of those, and there's only one constant. So this is it right here. It's completely simplified, and so we have nothing more to do. We're done. And again, how did we get there? We took the formula, replaced the x with a plus h. Now we're going to hold on to this result here because we're going to use it in problem 5 coming up right now. Okay, so now on to problem number 5. I'm asked to calculate and simplify this fraction here, f of a plus h minus f of a minus h. This fraction has a specific name to it. It's called a difference quotient, and it's a key algebraic construction that we use a lot in calculus. And if you're viewing this screencast prior to the end of chapter 2, just wait and see. We'll see this kind of difference quotient show up a lot in the development of what we're going to eventually call a derivative. Now there's 4 steps to computing a difference quotient. If you just take them one at a time, this isn't so hard. First of all, I have to compute the numerator, and then I have to divide off by the denominator. There's 3 steps in computing the numerator, though, which gives me 4. I first of all have to calculate f of a plus h. Then I need to calculate f of a. Thirdly, I need to subtract them. And then fourthly, I have to divide off by h. So let's go over and do this one at a time. So first of all, f of a plus h. You know, you can save a lot of time by just simply looking up at problem 4 and realizing that you did this already. So we don't need to redo anything. Let's just copy down the work. So the answer there was 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 3. Okay, that's already been done. So f of a now, the second step here, f of a is just what you get when you replace x with a in the formula for your function. So that's 2a squared plus 3a minus 3. And that's easy. And now I just need to subtract these two things. Let's do that real quickly. Now there's one tricky step here that a lot of students make a mistake on. Let's make sure we avoid this. Listen, first of all, just to copy down everything. Plus 3a plus 3h minus 3. And here's the step. I'm supposed to subtract off f of a. Now f of a has 3 terms in it, so I need to parenthesize the thing I'm going to put in here that I calculated for f of a. 2a squared plus 3a minus 3. Okay, why the parentheses? Well, let's carry out the operation here and just see what happens. Okay, all this stuff remains as is. I'm going to copy it down, though. Okay, now I have to subtract everything in this parentheses. So I'm subtracting the 2a squared. I'm also subtracting the plus 3a, and I'm also subtracting the minus 3. Okay, so we have a sign change on everything. Now here's where the parentheses come in. If you don't parenthesize that, this sign change here and this one right here will not take place, and they'll lead to some pretty bad results. As it is, though, we've done this correctly, so let's see what happens here. Well, I see a lot of like terms I can cancel out. There's a 2a squared and a 2a squared that are added and subtracted. There's a 3a and a 3a that's added and subtracted, and same thing for this 3 here. So here's my result, not for the whole problem, because I still have to divide by h, but it's a 4ah plus 2h squared plus 3h. And that's the numerator. Okay, that's this whole... If I can just delete all this stuff out, that's what this top part is equal to. Okay, everything up here. Okay, so let's finish this problem up here. Now I have to simplify this fraction. The numerator on this fraction we just discovered is 4ah plus 2h squared plus 3h. And the denominator on it is an h. So, question, is this completely simplified? No, I don't think so. I see a common factor on h on each of the terms on the top here. So let me factor off that h. I'll put it in red to show where it's coming from. What's left over is 4a plus 2h plus 3. And this is all over h. So I'm factored, and now that I've factored, I can cancel. I see the common factor of h here, and here it's gone. And here's my final answer, 4a plus 2h plus 3. The one thing I want to definitely avoid in this step right here is the common mistake of crossing off one of the terms here. That's not correct because canceling off is division, and if I don't have a common factor factored out, I can't divide. So you should never cancel things out before you factor things. So there's my answer, 4a plus 2h plus 3, combination of calculating function values and then just following the 4 steps for computing the difference quotient.